have that feeling you're talking to someone who's brilliant, but also a compulsive liar? Well, that's kind of the vibe millions of us get from the AI tools that are supposed to be changing our world. Today, we are diving deep into the hidden flaw in AI's code, the thing that makes them lie and also makes them burn an insane amount of energy. And we're going to reveal the incredible revolution in both software and silicon that's being built right now to fix it. Let's dive in. All right, so let's start with the big question on everyone's mind. Why do these incredibly smart systems lie? Or, as the people in the industry call it, why do they hallucinate? You've seen it. They just invent facts, make up fake legal cases, and spew total nonsense with this unshakable confidence. And this isn't some rare glitch, okay? It's happening everywhere across every single major model, from GPT to Gemini. You know, this one comment from a public AI forum it absolutely nails it. See, the models we use every day, they aren't really designed to be truthful. They're designed to be fluent. Their whole reward system is based on generating a plausible-sounding answer, on just predicting the next word in a sentence. There's literally no reward for saying, you know what, I don't know. And that is the absolute crucial point here. Hallucination isn't some bug that they can just patch out later. No, it's a fundamental feature of the way they're built right now. Think about it like this. Imagine a student who's been told they'll get an F if they leave any question on a test blank. What are they going to do? They're going to write something for every single question, even if they have to make it up on the spot. The system is built to guess, not to admit when it's out of its depth. And that right there leads to our first huge crisis. So this one single flaw in their architecture has kicked off two massive, unsustainable problems. The first one is what we've been talking about, the crisis of truth, these constant, confident hallucinations. But there's a second one that's just as serious, the crisis of power. Because the very same design that makes these AIs so fluent also makes them incredibly, unbelievably inefficient. And this is where the problem gets really tangible. I mean, look at this. A single standard query to an AI can use as much electricity as boiling a kettle of water. Meanwhile, a simple web search, it uses just a tiny, tiny fraction of that. This level of energy consumption, it just doesn't scale. You can't build the future of intelligence on a foundation that needs this much raw power. It's basically a dead end. So if the blueprint we're using right now is fundamentally broken, if it's stuck in both a truth crisis and a power crisis, what's next? Well, the most brilliant people in this field aren't just trying to patch up the old system. Nope, they're literally throwing out the old blueprint and starting completely from scratch. And it all begins with the software itself. For the last few years, AI has been totally dominated by one single architecture. It's called the transformer. You might have heard of it from that famous paper, Attention is All You Need. It's the engine that runs pretty much every model you know, especially GPT. But now, a whole new wave of thinking is emerging that goes way beyond the transformer, creating a completely new foundation for how an AI can think. And what we're seeing is this explosion of brand new ideas. We've got things like liquid foundation models, which are built to be way more adaptable. They actually change their own parameters on the fly to be more efficient. Then you have these new state space models like Mamba, which are coming in to challenge the transformer by processing information in a smarter way, avoiding those huge computational costs. And then there's differentiable programming, which is a massive paradigm shift that optimizes the entire process of analysis, not just the AI part at the end. This is a brilliant way to picture it. Instead of just training the AI model at the very end of the line, differentiable programming makes the entire chain, from the first moment you filter the data to the final answer, into one single, seamless, optimizable system. It's kind of like being able to tune not just your car's engine, but also the driver, the road conditions, and even the weather, all at the same time, just to get the fastest possible lap time. Now, these breakthroughs in software are absolutely incredible, but they're only half the story. Because the deepest, most profound change, the one that really truly solves both the power crisis and the truth crisis, it isn't happening in the code. It's happening in the hardware, in the silicon itself. We are standing on the edge of a hardware revolution that's taking its notes from the most efficient and powerful computer we've ever known, the human brain. This is the big shift, moving away from purely digital computing towards something totally new, analog and neuromorphic systems. You know, for our entire lives, computers have been built on digital logic. It's a world of absolutes, of ones and zeros, on or off, like a light switch. And that's great for doing perfect math, but it takes a ton of energy. The brain, though, it works more like an analog dimmer switch. It operates in shades of gray, in a whole range of values. It's not perfect for exact math, but it's wildly efficient for the kind of fuzzy pattern matching that intelligence is really all about.
And this whole new approach has a name: neuromorphic computing. It's all about building computer chips that don't just run software that acts like a brain, but are physically structured like a brain. It is a complete and total rethinking of what a computer chip can even be. And the advantages here are just profound. By copying the brain's distributed structure, these new systems absolutely slash their power consumption. They're designed from the ground up for constant learning and adapting. And they're built with revolutionary new parts, like memoristors, that basically act like artificial synapses in the brain. So, how efficient are we really talking about here? Get this. New research has shown that some of these artificial neurons can be activated with just 200 attojoules of energy. An attojoule is 1/quintillionth of a joule. That number is so ridiculously small, it's almost impossible to even wrap your head around it. What this means is we're heading towards a world where the energy cost of a single computation is getting closer and closer to zero. This doesn't just solve the power crisis we were talking about earlier, it completely obliterates it. This one change fundamentally rewrites the economics of artificial intelligence, forever. So what happens when you combine AI software that's actually designed to be truthful with hardware that can compute using almost no energy? Well, you don't just get a slightly better chatbot. You get the fundamental building blocks for a completely remade world. This is the real path forward. These new systems are going to be multimodal. They'll be able to see, hear, and read all at once. They'll combine the pattern-matching superpowers of neural networks with the strict, careful logic of symbolic reasoning. That's how you tackle the crisis of truth head-on. And this is how we get to real artificial general intelligence. Not by just making the old, flawed models bigger, but by building on this new, efficient, brain-like foundation. Okay, so what does all of this actually mean for us, for our careers? Look, while some jobs are going to change, this revolution is also creating an explosion of new high-value roles. The World Economic Forum is projecting huge growth for AI and machine learning specialists, for data scientists, and for robotics engineers. This tech isn't just a job killer, it's an engine for creating entirely new industries we haven't even thought of yet. When you really get down to it, this next generation of AI, it's not about replacing people. It's about creating true collaborative AI. Powerful, efficient, and truthful partners that can amplify our own creativity and help us solve the kinds of problems we could never, ever tackle on our own. So, I'll leave you with this one thought. We are building machines that are getting closer and closer to the incredible elegance and efficiency of the human brain. When we finally get there, when we have intelligence that is both powerful and sustainable, what great challenges of science, of medicine, and of society will we finally be able to solve?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.